Maths for Real mission for today is to put the funk back into quadratic functions. A quadratic function is a type of mathematical expression, and you need to be able to recognise one and know what its graph looks like.
So why am I standing in a field in the middle of nowhere? Well, there's nothing over there. There's nothing over there. That's because they're all up there. These aerial daredevils are competing in the first Speed Skydiving World Cup. Ian Chapman is the UK's top skydiver, closely followed by Ruth Cavell. OK, so tell me, what's the difference between speed skydiving and normal skydiving, obviously apart from the word speed?
Well, basically it's your body position. In normal skydiving, in flat flying, you are belly to earth and you have a big stable spread position and arch position. But in speed skydiving, you need to minimise the amount of surface area, so you're pretty much a head down.
So Ian, and how does actual competition work then?
Competition works basically by a skydiver being timed through a vertical kilometre during the skydive.
So what sort of time does it take to do this kilometre?
The fast boys at the minute are 250 to 300 miles an hour. You're looking about 7.5 seconds, 8 seconds to do a kilometre.
Normally, if you're belly flying, if you're in a stable spread position, it would take probably 18 seconds, maybe 20 seconds. So it's less than half the time. That's how fast you're going.
Now, the only thing that stops these speed freaks, or nutters as I like to call them, is air resistance. Now, if there was no air resistance, then the time taken and the distance fallen could be linked by this mathematical expression, d equals 5t squared. Now, it's a quadratic function where d equals the distance fallen in metres and t equals the time taken in seconds. Now, I can use this expression to get a table of values, and as if by sort of televisual magic, I just happen to have a table of values already prepared for me. And at 0 seconds, d equals 0 metres, obviously. And after 1 second, d equals 5 metres. After 2 seconds, d equals 20 metres. But what about the distance fallen after 3 and 4 seconds? Well, when t equals 3, t squared equals 3 squared, which is 9. And 9 multiplied by 5 is 45. And when t equals 4, t squared equals 4 squared, which is 16. And 16 multiplied by 5 is 80. I can take the pairs of values of t and d and plot a graph. The vertical axis shows the distance d in metres, and the horizontal axis shows the time t in seconds. Next, plot those points. Now, you may think that the path of the points forms a straight line. But if you actually trace the path of the points, you'll see they follow a smooth curve. Now, I'm lucky enough to have a smooth curve. You probably won't have this. So don't use a ruler. Just do your best using a sharp pencil to draw a curve. Theoretically, if a speed skydiver really could fall with no air resistance, they'd take just 5.29 seconds to cover that vertical kilometre. A kilometre in 5.29 seconds? Hey, that's not maths for real. That's madness for real.
Here's the graph that Jamie's just plotted for the quadratic function d equals 5t squared. In exams, you're more likely to see this type of graph and expression in terms of x and y. Replace d with y and t with x, and it becomes y equals 5x squared. The labels on the axes change too. X replaces t on the horizontal axis, and y replaces d on the vertical axis. The shape of the graph remains the same, but it's really only half the picture for this quadratic function. So far, we've only used positive values, but here is the table of values from -4 to 0. I've worked out x squared and multiplied that by 5 to get y. The important thing to remember here is that any negative number squared always gives a positive number. Plot these values of x against the corresponding values of y and see what happens. The complete picture for a quadratic function y equals 5x squared is a symmetrical bowl or U-shaped curve known as a parabola.
There are two key things to recognising a quadratic function.
And to help you remember, we've come to Trafalgar Square.
But why Trafalgar Square?
Because squares, and I'm not talking about you, are your first clue to spotting a quadratic.
A quadratic function always has an x squared. That's x to the power of 2. And there are no higher powers of x.
The second clue is in the graph. When you plot a quadratic, it's always a parabola.
Keeping those facts in mind, you're now ready to square up and play Spot the Quadratic.
You've got to spot which expressions are real quadratic functions and which ones are the jokers in the pack. Y equals 3x minus 4.
No x squared, and looking at the graph, not a curve in sight. That's not a quadratic.
Y equals x cubed plus 3x squared minus 4x.
The highest power of x is 3, not 2. It's not a parabola, not a quadratic.
Y equals 6 plus a half x squared.
Ah, at last, there's an x squared. It's a parabola. Definitely a quadratic.
I'm at the British Motorcycle Federation's final summer party, and if you like bikes, leather and the smell of an engine, then this is the place to be. I'm here to meet the world record-breaking king of quad biking, better known as the Kangaroo Kid. Come on, George, let's burn some rubber. I don't want to be late. Known to his mum as Matt Coulter, the Kangaroo Kid holds the quad bike world records for land speed and for jumping over the most vehicles. This professional stuntman will jump over just about anything that's put in his path. He's even jumped an aeroplane in flight. What about the most amazing stunt you've ever done?
I don't know if it's amazing or stupid, really. I was jumping his paddle steamer boat and I smacked into the top of it. And back with the back wheels and over this somersault like this, and my bike went flying off and I just somersaulted and landed in the water, big belly flop.
So what can you do to make sure that the jump is safe?
We need to make sure you've got enough run up to get up to the desired speed and to jump over whatever you're going to jump. And the angle of the ramp is most important as well.
Yes, son of a...
For each amazing stunt, the height, that's how high Matt could go, and the distance, how far he could travel, are actually linked by a quadratic function that looks like this. H is the height in meters above the ramp, and D is the distance that he travels. In each case, the quadratic function depends on the angle of takeoff and how fast he's going. So if the ramp was at 25 degrees and Matt was going at a speed of 56 miles per hour, the quadratic function would look like this. H equals 0.5d minus 0.01d squared. So Matt, if those were the conditions, how high do you think you'd go and how far do you think you'd jump?
Around about 6 metres high and 35 to 40 metres in distance.
To check if Matt is right, I need to draw a graph of the quadratic function h equals 0.5d minus 0.01d squared. And here it is. On the vertical axis, I've got h, which is the height in meters above the ramp, and on the horizontal axis, I've got d, which is the distance of the jump, again in meters. Because it's the graph of a quadratic function, I'm expecting a parabola. Now, it's an upside-down parabola, and that's because there's a negative sign here in front of the squared term. So, what does the graph tell us about Matt and his quad jumping? Well, this point here is the maximum value of h. That's the maximum height that he could reach during this particular jump. Reading across to the vertical axis, that's at 6.25 metres. Matt guessed 6 metres, so pretty good there. The second interesting point is down here, the jump distance. It's 50 metres. Matt guessed that he could jump 40 metres, so he seems to be pretty clued up about his quad biking. This is probably the closest I'm ever going to get to doing a quad bike stunt jump. See if you can do better in this week's Tick or Trash. It's that part of the programme when we both tackled the same question, but only one answer will be right.
The other will contain a deliberate mistake that you've got to spot. So watch carefully to decide if you're going to tick it or trash it.
On the grid, draw the graph of y equals 2x plus x squared. Use values of x from -4 to 2. Pens on your marks, set, go!
On the grid, draw the graph of y equals 2x plus x squared. Use values of x from -4 to 2. First, I completed the table of values to work out the points for the graph. The points I plotted were -4, 8, -3, 3, -2, 0, -1, -1, 0, 0, 1, 3, and finally 2, 8, which gave me this curve-shaped graph like this.
Here's my table of values. The points to plot are -4, -24, -3, -15, -2, -8, -1, -3, 0, 0, 1, 3, and finally 2, 8. And when I plotted the points that fitted on this grid, this is the graph I ended up with.
So who's working out slick enough to get the tick and who's going to crash out with the trash? Did you spot the mistake?
Is Jamie's graph the one you would expect for y equals 2x plus x squared?
Or should the graph of a quadratic function look like the one Katie's drawn?
OK, the game's up. It's my graph that's wrong. This wonky line is a dead giveaway. I knew something was up as soon as I tried to plot -4, -24, and -3, -15, because these points don't fit on the grid I've been given. My mistake was here. When a negative number is squared, it always gives a positive number, but I wrote them down as negative numbers. Because these are wrong, the corresponding values of y are also wrong.
Remember, the clue is in the expression and the shape of the graph. It's a quadratic function, so the shape of the graph should be a symmetrical U, a parabola like this.
This is the way to remember which way up the curve of a quadratic function will be. You can think of the graph for a positive x squared as a happy parabola, and the graph for a negative x squared as a sad parabola.